Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from definite integrals involving the modulus function, right? So here we have to find the value of this integral from 0 to pi by 2, and the integrand is sine of mod of 2x minus a, where a belongs to this closed interval 0 to pi, right? So here we see that we have this mod function, that is mod of 2x minus a, right? So let us start. So here we'll make use of a very important method of integration, that is substitution method, right? So let us call this integral as I, and here we'll make use of the method of substitution. So let us take t is equal to 2x minus a, right, where a is a number which belongs to this closed interval 0 to pi. Now differentiating t with respect to x, we have dt over dx is equal to 2 times 1 minus 0. Because the derivative of x is 1, the derivative of a is 0, being a constant, right? So this is 2. So dt over 2 is equal to dx, right? Because from here we can write dt is equal to 2 dx, and dt over 2 is equal to dx, right? Okay, now whenever we use the method of substitution, we always change the limits, right? So here the lower limit is 0, the upper limit is pi by 2, and since by method of substitution we are introducing a new variable t, so here x varies from 0 to pi by 2, right? So let us find the corresponding value of t. So when x is 0, then the value of t is 2 times 0 minus a, that is minus a, right? So here we'll substitute x is equal to 0. Now when x is pi by 2, the value of t is 2 times pi by 2 minus a. So this 2 and this 2 get cancelled. So we are left with pi minus a, right? So when x goes from 0 to pi by 2, then t goes from minus a to pi minus a, right? So now this integral I can be written in terms of t as minus a to pi minus a, and here we have sine of mod of t, right? Because 2x minus a is t, and for dx we can now write dt over 2, right? We can take half outside the integral, so we have minus a to pi minus a, and here we have sine of mod of t dt, right? So viewers, now we have this integral to evaluate. Now see, here what we will do, will make use of the definition of mod function and one important property of definite integrals. Now see, we know an important property of definite integrals, that is integral from a to b f of dx can be written as a to c f of x dx plus c to b f of x dx, right? When c, it lies between a and b, right? So this property shall be used here. So before applying this property, let us see the definition of mod function, right? Now see, mod of t is defined as positive t whenever t is greater than 0, right? Mod of t is 0 when t is equal to 0, and mod of t is minus t whenever t is less than 0, right? So now what we will do, we'll write this integral as a sum of two integrals, right? So the first one goes from minus a to 0, right? From minus a to 0 we have sine of mod of t dt, and the second one is from 0 to pi minus a, and here we have sine of mod of t dt, right? So we have written this integral as a sum of two integrals, and this value, that is this point 0, it lies between minus a and pi minus a. Now see here, this point is 0, it lies between minus a and pi minus a, right? See, a belongs to this interval, that is 0 to pi. Now let us take a is equal to pi by 2 as an example. Then we can see that we have minus a. So minus a is minus pi by 2, right? And what is pi minus a? Pi minus a is pi minus pi by 2. So this is 2 pi minus pi over 2, that is pi by 2, right? So it means we have to integrate from minus pi by 2 to pi by 2, right? So between minus pi by 2 and pi by 2, we have the point 0, right? So we go from minus pi by 2 to 0, and then we go from 0 to pi by 2, right? So that's why we have written this interval as a sum of two integrals, and 0 is the point where we have split this integral into two parts. So now let us take this integral as I1 and this integral as I2, right? So I is now equal to half, and we have I1 plus I2, right? So we'll separately solve I1 and I2. So I1 is integral from minus a to 0, right? And we have sine of mod of t dt, right? Now see, here we have minus a to 0. So all the values are negative because t, it goes from minus a to 0. Now see, here we have 0 and here we have minus a, right? So all the values which lies between minus a and 0 are negative, right? So when t is negative, then mod of t is equal to negative of t, right? So mod of t is minus t when t lies between minus a and 0. So we have now minus a to 0, and here we have sine of minus t, right? Because mod of t is now replaced by minus t. Now from trigonometry, we know that the sine of minus theta is equal to minus of sine theta, right? So this is negative of minus a to 0 and sine t dt, right? So sine of minus t is minus sine t, and taking this negative sign outside the integral. Now integral of sine t is minus cos of t, right? And the limits are from minus a to 0. So this negative and this negative becomes positive. So we have cos of t, and the limits are from minus a to 0. So this is cos of 0 minus taking t is equal to 0 and then taking t is equal to minus a. So we have cos of minus a. So cos 0 is 1, and here again from trigonometry we know that cos of minus theta is equal to positive cos theta, right? So cos of minus a is simply cos of a, right? So the value of I1 is equal to 1 minus cosine a. So now let us take I2. So I2 is integral from 0 to pi minus a, right? And here we have sine of mod of t dt, right? Now see, here t, it goes from 0 to pi minus a, right? So let us see this interval, that is closed interval 0 to pi. Now here a belongs to this interval, that is 0 to pi. So we can now write a is less than or equal to pi, right? From this interval, right? Because a belongs to this interval. So a is either less than pi or equal to pi. right? Now if we multiply this inequality both sides by -1, then we have minus a is greater than or equal to minus pi, right? So here we have left this 0. We are only considering this pi, right? So now adding both sides pi, we have pi minus a is greater than or equal to minus pi plus pi, because adding pi to both sides we have pi minus a, that is greater than or equal to 0, right? So it means pi minus a is greater than or equal to 0. It implies that it is positive, right? So when t is positive, that is t is greater than 0 or t is equal to 0, we have mod of t is equal to t, right? So now I2 is 0 to pi minus a, and here we have sign of simply t, right? So mod t is equal to positive t when pi minus a is positive. So now the integral of sine t is minus of cos t, and the limits are from 0 to pi minus a. So this is, we can take negative sign outside. We have cos of pi minus a, and then we have cos of 0, right? Substituting the limits and taking the difference. Now from trigonometry, we know that cos of pi minus theta is equal to negative of cos theta, right? So we have minus cos of a, and cos 0 is 1, right? So minus minus becomes plus here. Similarly here also we have plus 1, right? So the value of I2 is 1 plus cos of a, right? So now the total value of I is half, and we have I1 is 1 minus cos of a, right? And I2 is 1 plus cos of a, 1 plus cos of a. So cos a and cos a get cancelled. We are left with 1 plus 1, 2. So I is half times 2. So 2 and 2 get cancelled. So we are left with 1, right? So the value of this integral is equal to 1, right? So viewers, this is how, by making use of the concept of a mod function and the properties of definite integrals and other important results from algebra, we can solve these type of integrals.